This video is going to be on evaluating logarithms, and we're going to do it without a calculator. So obviously if you have a calculator like a TI Inspire, you can evaluate a logarithm such as like log base 2 of 3 in a calculator just by plugging it in, and it'll give you some decimal. But what we're going to do is we're going to have these be a little bit nicer, and we're not going to do ones like that, but we are going to evaluate logarithms without a calculator, so the bases will have to be nice as well as the numbers that we're taking the logarithm of. And so a logarithm is related to an exponential function. Just want to remind everyone that y equals b to the x is a very basic exponential function, and its inverse can be written as the log base b, the base is the same, of y, and it equals x. And so the way a logarithm works is the logarithm is basically stating this base, what is the exponent that would make this base equal the y value that's on the inside. And that's really what a logarithm is asking. So for instance, if you have the log base 2 of 8, you could think of it this way. 2, that's where you start, 2 to what power, and I'm going to put an x there to represent a number, right? 2 to what exponent would equal 8? And so you just want to think about it. 2 times itself, how many times would equal 8? And the answer would be 3. And so the log base 2 of 8 equals 3. And that's how you actually, as simple as I can state it, evaluate a logarithm. But let's look at a few different situations. So the first situation that we'll take a look at is if somebody were to say, what is the log of 100? You say, well, you just told me that I needed a base, and I can't see it. One thing to notice is that if the base is not written, then it is assumed that the base is 10. Okay, so now as you look at this situation, you can say to yourself, 10, right? 10 to some power x, don't know what it is, would equal 100. And whatever that exponent is, that's what the logarithm will equal. So 10 squared is 100, so the log of 100 equals 2. Let's try a couple more, right? Let's go with the log base 3 of 1 over 9. So still going to rewrite it as an exponential. So you would take the base 3, it's going to be raised to some exponent, and it's going to equal 1/9. And so the kind of exponents, right, that could take a 3 and flip it, make you take the reciprocal, and then be a 9 on the bottom, would mean that this thing needs to equal a negative number, right? Negative exponents cause you to take the reciprocal. So if you think about it, 3 to what power is 9? The answer is 2. And so then negative 2 would be what you want to go with, because 3 to the negative 2 would get you 1/9. And so the goal here is to evaluate a logarithm. Really, I try to get students to think of it as an exponential and say to themselves, what would the exponent need to be in order to make that base equal the number on the inside? Okay, a couple other ones that are just really important for you to know will look like this. Okay, so the log of 1. So once again, you say to yourself, all right, what is the base? The base is 10, and 10 to some power needs to equal 1. And so if you think about what would the power be that would make 10 equal 1, and the power is 0, right? The 10 to the 0 power would be 1, and actually anything to the 0 power is 1. So it could be log base 2 of 1 would equal 0. Or log base 3 or 4 or 5. It doesn't matter what the base is. If 1 is inside the logarithm, then the answer will equal 0. And then there's one last thing I want to say, and it's this. The log base 2 of -4, right? If you were to rewrite this, you would rewrite it as 2 to some power equals -4. Now you may be thinking to yourself, all right, 2 to the second is 4. And if you did 2 to the -2, based off of this problem up here, we know that 2 to the -2 would be 1 over 4. And so it wouldn't be -4. So the question would be, what could x be in order to make that equal -4? And the answer is nothing. You can never take the logarithm of a negative because you'll never find an exponent that will make the base become negative. So it's not possible. Right? And that's kind of a quick introduction on how you evaluate logarithms without a calculator. All right, have a great day.